We'll proceed in vector summation integral. Okay, so vector summation and integral calculus that we have waged war against it. Can I divide my problem into n different parts and then solve part by part and then assemble it and then you got the solution? Okay, provided what is the kind of prerequisite for it. If I'm dividing my problem into n different parts, then make sure that each part is independent to each other and they look identical. Like we have given example of, if I'm tossing n number of coin, if I have n number of coin and tossing n number of coin, and then I'm trying to tackle some issue. Probably there can be many problems associated with the n number of points. One problem can be, what is the average number of head I can imagine or I can expect, average number of head. If I toss n number of coin, what would be the average number of head that I would expect? And that average number of head, if I am trying to calculate, then I am seeing that all coins outcome is independent to others. Each coin outcome is not dependent upon other coin outcome. So this is typically falls in IID scenario. Independently, okay, identically independently distribution. So if I find the average value of head in one coin, a coin has head or tail, or average number of head in one coin, where probability of getting head may not be half the way people expect. The probability of getting head in one coin is half. It may not be the case. It can be P. It can be P. Okay. P and 1 minus P. P means probability of getting head and 1 minus P is probability of getting tail. But P may not be zero point 0.5. This is what I am saying. If I get the average probability of getting head for the one coin, then I can add for all the coin and I get the solution. This is far easier. This is typically called Bernoulli's distribution. And then I add for n rather than calculating the average number of head for n coin altogether. This falls in binomial distribution. That is difficult. So the concept is, if I know that my problem can be divided into n different parts and then we can tackle part by part and then solve it. This is this is typically called dividing. This is typically falls in the dividing problem in n different parts and then means summation, solving problem part by part and then coming to a concept of summation. Okay. Is there anything we can see? We will proceed and then we will see if we will tackle, if anything, something that we have not talked about, if it comes into the picture. Okay. Now we are in phase of calculating the bank interest. Bank interest. Like like I am giving Y0 amount to the bank, claiming I want to start a fixed deposit. Fixed deposit means you give some amount to the bank and bank would take that amount and it will declare, we are giving interest annual basis and this is the interest. If interest rate is 5%, then after 1 year, whatever I have deposited, if I have deposited $100, 100 ruble, 100 rupees, 100 taka, or 100 euro, 100 pound, then $100 will become $105 after 1 year. And then $105 will become principal amount after 1 year. And then the profit, the interest rate 5% will be calculated on top of A. Make sense? This is, if I take, there are two ways to understand it. I am saying that the interest that is provided on the money I have deposited in the bank, that interest rate is 5%, but 5% is annual interest. Annual interest. Every year, anyone would get 5%. But if I visit a bank, the bank is saying that you would get your interest and your principal amount that will become your principal amount after 1 year. If you deposit $100 and at 5% after 1 year, your $100 will become $105 with the interest. And for the next year, $105 will become principal amount. Then for next year, the net money will be 105 plus 5% on 105. Whatever is there, full will become principal amount and it will proceed in that manner. Okay, if someone is watching carefully, consider consider the interest rate is 5%. Okay, then how much it will become after 1 year? If I say I have deposited $100, then $100 would become how much after 1 year? This is the question I'm asking. Okay, then it will be 100 plus 100 plus 100 into the interest rate. Okay, then I can take out 100 and it will be 1 plus interest rate, that is 5%, that is 0.05. 1 plus 0.05. Can I make 1 plus 0.05 as an amount called A? A. In that manner, after 1 year, how much money I am getting? A into Y0. Y0 is the amount that I am depositing in the bank at the in the fixed deposit at the beginning only. Y0. So Y0 would become Y0 into A. A is 1 plus the interest, annual interest. If like so, then after 1 year, Y0 into A will become principal amount. And then I have to again multiply, then what will be the net amount after one at the end of 2 years? Then Y0 into A. Y0 is the begin amount that I have deposited in the fixed deposit. So Y0 into A is the amount I am seeing after 1 year. Okay, now on top of it, what I can expect at the end of 2 years? Y0 into A is the principal amount plus Y0 into A into Y0 into A into 5%. Okay, then I can take out Y0 into A and it will become 1 plus 5%, 1 plus 0.5, more or less that is A1. Okay, so it becomes Y0 into A square, Y0 into A square. So if I had deposited Y0 money in the account at the beginning, after 1 year it become Y0A. After 2 years it become Y0A square. Then after 3 years it will become Y0A to the power 3. After t years Y0 amount will become Y0 into A to the power t. T can be small t. Now I can say that if someone has deposited money in the account, if someone has deposited money in the account Y0 at the interest rate of 5%, okay, if I say A equal to 1 plus 5% or 1 plus 0.5, 0.05, then after end of t year, I can expect my Y0 to become Y0 into A to the power t after t year, where A is 1 plus 5%. Okay, or 1 plus c. C is the interest rate. 1 plus c. C is the interest rate. Can I demonstrate in other terms also? Someone would say that interest is nothing but dy by dt. Y is the amount at any time. Y is the amount at any time in the bank. Y0 is the amount at the times t0 in the bank. I'm sorry, yeah, dy by dt, dy by dt per unit time. Dy by dt means per unit time how much the balance is changing. That is the interest. If I take time per unit time, if the unit I am taking for the time is 1 year, then per year how much balance is changing, that is dy by dt. So dy by dt, how much interest I am seeing after 1 year, that is dy by dt, where dt is 1 year, equal to C into Y, interest, interest. I'm not talking about the net amount I am seeing at the end. Okay, net amount I am seeing at the end is 1 plus C. C is the interest rate, 5%. 1 plus C that I am calling at A. A into Y0. That is the net amount I see after 1 year. Okay, what is the interest I am seeing after 1 year? dy by dt, where per unit is 1 year. dy by dt equal to dy by dt equal to c into y. Y c into y. Y is the current. I can, for timing, I can say y0. So at the after 1 year, I can say C into Y0 is the net interest I am seeing after 1 year. Okay, let's take this is what the Mr. Euler has done. Let's do dy by dt is nothing but yt plus delta t minus yt by delta t as per the fundamental, where delta t is 1 year. Yt plus delta t minus yt by delta t dy by dt. Dy by dt is interest that is accumulated when the y0 amount went for delta t times, and that will be multiplied with the c, y into c. Okay, now let's settle it down. Y, there we have y into c. There we have y into c. Okay, that I can call it yt. Dy by dt equal to y into c. Okay, now if I'm not talking about the first year, anytime, then it is y into c dy by dt. dy by dt with the first differential equation, first principle of differentiation, it will become y and in bracket t plus delta t minus y t divided by delta t equal to c into yt. If I take delta t that side, that becomes c delta t yt. Yt means y and in bracket small t, y as a function over t. So now we have yt plus delta t minus yt equal to yt, c and delta t. If I take yt that side, then it becomes y plus yt plus delta t, yt plus delta t equal to yt plus yt c delta t. If I take out yt from that side, it becomes 1 plus c into delta t. I believe it is alright. Okay, this is mind-blowing statement we are making. Y in bracket t plus delta t equal to y and in bracket 1 plus c delta t. Consider delta t is 1, then it becomes yt plus 1 equal to yt 1 plus c. 1 plus c I am calling it as a, means yt plus 1 equal to a into yt. Can someone believe that we can bring the formula through interest rate also, that is dy by dt? dy by dt becomes y and in bracket t plus 1. T is in a small letter. T plus 1. If I know the balance in my account in the fixed deposit as y at end of any t number of years, then I'm trying to get what will be the balance after t plus 1 number of years, t plus 1, y at t plus 1, where y is the amount in my fixed deposit at any time, whereas c is the interest rate I am enjoying per year. So y and in bracket t plus 1 equal to y in bracket t, yt, and then in bracket 1 plus c. 1 plus c, c is 5%. 1 plus c I can call it a. So yt plus 1 equal to a y into t. Makes sense? Okay. Now consider that I want to have the y amount at the end of 1 year. Then t will be 0. Y at the end of 1 year I want. Y in bracket t plus 1. T is 0. Then y at the end of 1 year I want equal to y at 0 time, that is y0. Y0 into a will be the amount at the end of 1 year. What will be the amount at the end of 2 years? Then t I have to make 1. Y1 plus 1. Y at the end of 2 years equal to yt. Yt is 1. Y1 into a. So a into y1. What is y1? Y1 is same as y1 plus 0 or y0 plus 1, where t is 0. So I can rewrite it y of 2 years equal to a into y of 1 year. Y of 1 year, if someone remember, just now we talked, Y of 1 year is A into Y0, or Y of 1 is equal to Y 0 plus 1, where 0 is a T, equal to Y of 0 into A. So more or less y of 2 equal to a into y0, y0 a square. Similarly, y at any t, y at any t will become y at any t. Consider I'm trying to calculate y at t, then I'll take yt plus 1, there I'll take t as t minus 1, so that it will become yt equal to a to the power, a to the power, okay, I have taken here t as, okay, I have taken a t minus 1 whatsoever. Y of t will be a to the power t, the way we have calculated, into y0. Y of 2 equal to a square, a to the power 2 into y0. So y at any t will be a to the power t into y0. I believe this is all right. Means I am trying to calculate the y at any after any year is the a. A is 1 plus interest rate, a plus c, 1 plus c. A to the power a to the power t multiplied by y0, that is the amount someone deposited at the 0th year. So he would get that much. Now the concept is coming that someone his well wisher, this is what we are saying. Consider his well wisher, a person's well wisher. He is depositing S amount every year from sideways. Probably, probably S can be $10, Y0 can be $100. He had deposited $100 at the beginning, and then he is saying that how much it is becoming after T years. So YT will be Y0, that is $100, into A to the power T, where A is 1 plus 5%, 0.05, 1.05 to the power T after T years. This is normal kind of fundamental in the mathematics. People know it very well. Okay, what people they do not know is, consider some well-wisher is depositing S amount of money in this fixed deposit every year without I know it. Then at any year T, what will be the amount in the this fixed deposit? That is the question. Okay, if I see it, then if person is depositing S amount at the end of 1 year, then S amount, now the question is arising here. What is the kind of nature of the growth of the money? The nature of the growth of the money is, if whatever you deposit, it will become A to the power T year. If I deposit now some money in the account, then after T year that money will become that money multiplied by A to the power T. If in first year someone has deposited S amount of dollar from outside to the money, it is also called outside influence, external influence, that is called S. Okay, external voltage, external influence in the electronic circuit also. Okay, in that manner, what is the amount I have? If someone has deposited S amount around end of 1 year, then that amount after T year I am seeing that will become S into A to the power T minus 1, because full 1 year it will not get anything. Understandable, right? If this is time equal to 0, then at that moment someone deposited $100 in the account. That is the Y0. Someone deposited Y0 in the account. And then this is 1 year time span, and here someone deposited S amount in my account. Now, if I'm talking about T years, T 1 year, 2 year, 3 year, T year, how much money will be there in the account? So this Y0 has gone for full T years. Y0 into A to the power T, that will be money. If I talk about S amount, then it has lost first year. Then that S amount will become S into A to the power T minus 1. Similarly, if someone deposits S amount at the end of 2 years, then that S amount will become S into A to the power T minus 2. I believe you all right. Okay. Now what will be the money in the account? That is the question. Consider someone is checking at the end of 4 years. At the end of 4 years, then how much money he can expect? The first y0 will be y0 into a to the power 4. First s will become s into a to the power 3 because it will go for 3 years. Next s will be s into a to the power 2. Next s will be s into a to the power 1. Okay. Next will be s into a to the power 0. Then only here deposited. A to the power 0 is 1. If I take out s, then it will become s in bracket a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power 0, a to the power 0, 1. It will come at the end. Net money at the end of t year, someone can expect is y0 into a to the power t plus s, and in bracket s a to the power t minus 1 plus a to the power t minus 2 plus 1. Okay, what will be this amount a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 up to 1? Let's find out. Let's consider that this summation a to the power t minus 1 plus a to the power t minus 2 up to 1, the summation is considered as x, x equal to that much. Let's multiply s with a, x with a. Then I have x equal to a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power 1 plus a to the power 0. If I multiply whole term with the a, then it will become into a into s to the power a into, sorry, x is whatever we said. X into a will be a to the power t plus a to the power t minus 1 plus a. 1 will become, last 1 will become a. If I subtract this, then it will become x and a minus a into x and x. If I subtract, it will become x and in bracket a minus a equal to a to the power t, and rest of the thing will go away. And this side we have at the end we have a, and that side at the end we have a plus 1. Up to a will go away, 1 will remain. So it will become x and in bracket a minus 1 equal to a to the power t minus 1. Net x will be a to the power t minus 1 by a minus 1. So I can rewrite that amount y at the end of any t years yt equal to a to the power t y0 plus s, and in bracket a to the power t minus 1 bracket close by a minus 1. Now question is arising that is it the end? Is it the end? Is it what every bank is providing, or there can be more complexity out here? Or can I solve this a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 up to 1 through integral calculus? Someone would say no, not possible. Integral calculus is repeated summation. What do you mean by repeated summation? Repeated summation can be written as multiplication, and any multiplication can be written as integral calculus. All integral calculus cannot be written as multiplication, but every multiplication can be written as integral calculus. All summation cannot be written as multiplication. Okay, what I am trying to say, that consider, many times I have showed it. Consider this is a technology called multiplication. This is a technology called multiplication. This is technology called multiplication, and this is a technology called addition. Up, up. This is called addition. Up, up. This is addition, and this is integral calculus. Both are connected to multiplication. This is repeated addition. If I add items repeatedly, it will fall into multiplication. Multiplication. Or okay, so a multiplication can be represented through repeated addition. That is the better way of explanation. Multiplication can be represented as repeated addition, and this multiplication can be represented as integral calculus. Multiplication is the main item, central item. One fork is integration, one fork is repeated addition. Or if I have repeated addition, it can be brought up into multiplication, and then it can go into integral calculus. If I have integral calculus, it can brought be in multiplication, and then it can go in repeated addition. Whatever is feasible. What do you mean? If I say 3, if I say 3 into 4, if I say 3 into 4, 3 into 4, the 3 into 4 can be written as 3 plus 3 plus 3 plus 3, 4 times, repeated addition. It can be also written as 3 into 4. So if I have something like this multiplication, then one fourth is repeated addition. If I have 3 into 4, then it can be written as 3 plus 3 plus 3 plus 3. If I have 3 into 4, it can be written in integral calculus also. 3 into x, 3 dx from 0 to 4. 3 into x, 3 into dx, limit 0 to 4. Same thing, 3 into 4. So any multiplication can be written as integral calculus. Any multiplication can be written as repeated summation. Possible. Any two multiplication. Can I solve a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power 0 through integral calculus? Why you are doing like that? Because I think it is addition, and addition can be brought into multiplication, and then multiplication can be brought up with integral calculus. Probably no one would be talking like this. Okay, but it should be repeated addition. Here it is not repeated addition. A to the power t minus 1, a to the power t minus 2, a to the power t minus 3, a to the power 1, a to the power 0. All have power as different. It is not a repeated addition. Can we make it as a repeated addition? Where here t is variable. Consider t is fixed component. We have demonstrated a similar thing earlier also. Consider t is fixed component. If t is fixed component, then consider there is another variable called x. This is x and this is y. This is x and this is y. I have a variable called x. X is varying. When x is varying, what I am trying to say, when x is 0, when x is 0, when x is 0, then I have a vertical called a to the power t minus 1. When x is 1, then I have a vertical called a to the power t minus 2. If I have a vertical at x equal to 2, then I have a vertical called a to the power t minus 3, like that. Is it possible? Yeah, it's possible. If I have expression like a to the power t minus 1 minus x, I believe it is alright. Or a to the power t minus x, where x starts from 1, a to the power t minus x. Just write a to the power t minus x, a to the power t minus x, a to the power t minus x. This is what someone has to sum, where x is going from 1 and it proceeds in that manner. So if x is 1, then here it is a to the power t minus x, that is a to the power t minus 1. When x is 2, then again someone has a to the power t minus 2, a to the power t minus 3, when x is 3. Where x is 3. So I have a now repeated summation. Repeated summation is of a to the power t minus x. Everywhere I have a to the power t minus x, where x is varying, but it looks similar. So a to the power t minus x, a to the power t minus x, a to the power t minus x. How many times? X times. Then it can be written as a to the power t minus x into x, a to the power t minus x into x, where the first one, a to the power t minus x, is a function over x. So function over x into x can be rewritten as fx dx, where x has a limit from begin to end. So begin is 1, that is for sure. What is the end that we will see? So we have fx into x That is what we were trying to add. These are not available in any of the book, the what we have started now. A to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 up to a to the power 0 I am trying to calculate. I am rewriting it as a to the power t minus x plus a to the power t minus x, where x is varying and t is constant. Okay, in that manner, we can rewrite as a to the power t minus x multiplied by x time. If I do it x time. Now it can be written as function over x into x, because a to the power t minus x is function over x. So function over x into x, fx dx. X is big into n. E to the power a to the power t minus x, a to the power t minus x into x into dx. What is the integration of a to the power t minus x? That is under question. What is the integration of a to the power t minus x? That will be minus a to the power t minus x. Consider t minus x equal to y. Then dx equal to minus dy. Then a to the power y dy integration will be a to the power y by ln a, natural log of a. Okay, then it will be minus is outside already there. So minus a to the power t minus x by ln, natural log of base e of a. Okay, now let's settle down x. X is from 1, that is for sure. What about the end one? End one will be t, because at the end it has to become a to the power 0, that is 1. So 1 to t. Let's place t first. So it will become a to the power t minus t, a to the power 0, 1. So 1 minus, and then x is 1, a to the power t, a to the power x starts with the x equal to 1. So a to the power t minus 1. I believe it is alright. Okay, in that manner, it will become a to the power minus is outside. So it will become a to the power t minus 1. A to the power t minus 1 minus 1 by natural log of a. How much it is similar to what we calculated, a to the power t minus 1 by a minus 1. We are getting a to the power t minus 1 minus 1. I believe it is alright. A to the power t minus 1, a to the power t minus 1 by ln a. And then that side we have a to the power t minus, here we have a to the power t minus 1 minus 1 divided by ln a, and that side we have a to the power t minus 1. I'll rewrite it. A to the power a, if it is a to the power t minus 1, and then minus 1 divided by ln of a equal to, is it equal to what we calculated earlier? Earlier what we calculated is a to the power t and then come down minus 1 by a minus 1. This is what we calculated earlier. Is it the same? Okay, not same, certainly. They are different. When it will be same, why integral calculus what we are calculating is different to what we calculated through algebraic way. Algebraic way is a to the power t minus 1 by a minus 1. Through integral calculus we have a to the power t minus 1 minus 1 divided by ln a. Okay, we will proceed on this. Okay, what is integral calculus? Integral calculus, if I have fx dx, integration from one limit to another limit, then it will be more concrete where we chop our curve. Integral calculus says typically if I have fx and this is x-axis, this is a function over x, this is y-axis, this is function over x, this is x-axis. If I chop this x-axis into n part, when n tends to infinity, then I have n number of sub-area. If I add all n number of sub-area, that is the at any point, if I take any point x here, then what is fx multiplied by delta x? The delta x belongs to one of the n section I have created. So fx into delta x, summation for n equal to 1 to 1 to n summation I equal to 1 to n fx at x equal to isx into delta xi. If I go, that will be fx dx. Means delta x has to be very small. Now we have taken, okay, we have taken through repeated summation, that is different sign. We will try now to make delta x lex. We have taken 1 gap earlier. 1 gap. T minus x, where x is 1, 2, 3, 4. I'll try to squeeze it, the gap. Then we will see it will be really similar. A to the power t minus 1 by a minus 1. This is calculated through algebraic manner. And now we calculated a to the power t minus 1 by ln natural log of b. Okay, is it same? When it will be same, and those things that we will proceed upon. Mind blowing discussion that how I can solve any kind of summation and this kind of very complex interest and business economics condition through integral calculus. We will talk lot in this scenario. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is India country code 9483160610 a telephone number. What is the hint here? Consider that a person is going bank to bank, and every bank is saying that we are giving 5% annual interest. But one bank is saying 5% annual interest is true, but we are accumulating, we are summing the principal amount with the interest every 3 months. Okay, not every 3 months. We are doing 5 times in year. This is what one bank is saying. 5 times in year we are doing. What he is trying to say, after few months, 2 months, what will be 12 months by 5? 12 months by 5. It will come as 2.4 months. I think so. 12 by 5, 2 times, then 20, 2.4 months. If you deposit $100, then after 2.4 months at interest rate of 5% per year, then after 2.4 months, 4 months, you are entitled for 1% of the interest. Makes sense? Yeah, makes sense. Then we will make your $100 plus 1%, that is $1. $101 will become your principal amount after two months, 2.4 months. Then 1% will be calculated for next 2.4 months on top of $101. Whatever it becomes, then the new principal amount will be newer now. That will be more than $102. Then again 1% will be calculated on top of more than $102 for next 2.4 months. So after 5 months, after 5 tenure, after 5 terms within 1 year only, you will get more than $105 for sure. Probably you may get near to $106. And then again for next 2.54 months, next 2.4 months. Means we are doing recurring every 5 times in a year. One bank is saying like that. We are giving 5%. Then someone is very happy. No, he is not calculating. At the end, what is the formula? Formula is that now we have, formula is the actual interest is 1% only, but it is happening every 2.4 months. So earlier we calculated yt equal to a to the power t into y, where a is 1.1 plus the interest rate. Now we have 1 plus interest rate as 1% only, or whatever the yearly interest rate divided by n, how many times we are breaking 1 year. I have breaking 1 year in five times. So it will be 1 plus 0.05 by n, or 1 plus c by n to the power n, that is after 1 year, to the power t after t year. So yt equal to 1 plus c by n to the power tn into y0. Okay, but earlier we had a to the power t, or 1 plus c to the power t into y0. Both are different. Now we are making a small chip. Okay, if I do so, then will these two integrate, these two fundamental work bringing through the repeated through the integration and through algebra, that is a to the power t minus 1 by a minus 1. Now, will they come together as per the integration concept? Mind blowing, amazing. That we will see.